so this is just a quick video on how to do some basic trig identities, and it's just important to just memorize all of these because it will be important, and they are important, and you'll use them forever. So yeah, we're just going to start off with the obvious ones. If we know that sine, cosine, and tangent, these are going to be our basic trig functions, where this is O, opposite over hypotenuse. This is going to be adjacent over hypotenuse, and this is opposite over adjacent. And if we draw that on the triangle here, we have theta, and we're just going to assume this is 1. And let's say this is side B and this is side A, because they're across from the angles right here. We know that B is equal to sine theta, because it's equal to B over 1. And we also know that A is equal to cosine theta, because it is equal to A over 1. And then we also know tan theta is just equal to B over A, because it's defined as the opposite angle over the adjacent angle side. Anyway, from there, here are some definitions. So we're going to define cosecant as 1 over sine theta. So it's just the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the opposite of, or reciprocal of, tangent. And those are just ones you need to memorize, and that's how they are defined. Right here it gives you a nice identity where tan theta is defined to be sine theta over cosine theta, which is nice because we find that from this, because B is sine theta and A is cosine theta, so that checks out. And sine is a odd function, so if you input a negative, it will be the negative of the original function. And cosine is an even function, so if you input a negative, it will give the original function. As for tangent, it is also an odd function because it is based off the sine function. So that's just nice to remember, and it will be important to know for symmetry. Anyway, getting into it, we'll do the Pythagorean identity. So obviously, we're going to see from the triangle here that a squared plus b squared equals 1. So from here, we already know what a is, right? We define it as cosine, so cosine squared theta. And then we found what b squared is. We found it's sine theta plus sine squared theta equals 1. And this right here is the end-all be-all trig identity. This is the most important one. This is the one you will use the most. This is the one that shows up the most often. Gotta remember this. And it's really easy because it's just a Pythagorean formula. So from here, we can actually manipulate this a little bit. If we want to find it in terms of cosine squared x, you just make it cosine squared theta, subtract sine from both sides, equals 1 minus sine squared theta. So these are equal, so you got to remember that one. And if you want to find it in terms of sine, you can find it like this, and then it's 1 minus cosine squared theta. So you got to remember all of these. And for both of these, you can square root them to find just sine or just cosine. Find just the trig function. Because these are still in terms of squares, and those are a little complicated, so you can always just square root them. Anyway, so some alternate forms of the Pythagorean identity, other than the OG ones, or the original ones, is if we just write it down, cosine squared theta, sorry, plus sine squared theta equals 1. Think about dividing by cosine squared theta throughout, cosine squared theta throughout the whole thing. This is going to cancel out. This is going to become 1, right? And we already know sine theta over cosine theta is tan theta. So you have that twice, like this. That's equivalent. So really you just have tan times tan, which is tan squared theta. And remember, we defined that cosine, the reciprocal of it, is equal to secant. So this is really just secant theta times secant theta, because you have it twice, which is equal to secant squared theta. So that's another important one. And obviously you can do the same thing by dividing by sine squared theta, and that's going to give us cotangent squared theta plus 1 equals cosecant squared theta, because this time sine squared is going to be on the bottom. And if you want to see how we got that, that's going to be cosine squared theta over sine squared theta. Remember, that's just cotangent times cotangent, because both the top and bottom are squared, plus sine squared theta over sine squared theta, because we divide it, and that will become the 1. And then 1 divided by sine squared theta. It's the same idea as the cosine squared theta. It's going to be cosecant. It's going to be this times that, right? And this is just equal to cosecant times cosecant, which is equal to cosecant squared. Like that. Perfect. All right. Now, moving on. An important thing that you guys will be doing this year is proving that this is equal to that. So it's going to have like, prove this equation or prove this identity. Are these equal? And the way you do it is you choose one side and you try to make it equal to the other side using only trig identities. And you have to stay on one side. You can't change both sides. That's the whole point. You can't change both sides. And usually you want to choose the side that is more complicated, because it's always easier to simplify than trying to expand out and then simplify back down to something else. Because think about it. If we have, let's say we have some function, right, that is equal to both of these, it would be easier to just jump from here up to here, or sorry, this is kind of a bad drawing, but you want to take the bigger one and just simplify it down to this, instead of trying to expand this out and going back up to there. It's a little bit weird of it was a bit of a bad analogy, but it's always easier to start on the more complicated side, in my opinion. So from here, we're going to take this side, and we know that tan x is equal to sine x over cosine x. And then we have plus cosine x, and we can just leave it as plus cosine x for now. Oops, root of theta. And this is actually times sine theta. So this is actually going to give us sine squared theta over cosine x plus cosine x. So if we want to get another cosine x on the bottom, we got to multiply, so we can combine like terms. And this is going to equal sine squared x plus cosine squared x all over cosine x, right? And look, it's our Pythagorean identity right here. So we know that's equal to 1. So we're going to do 1 over cosine x. And this is defined to be secant x by the reciprocal identities. So that checks out. Perfect. So as far as these other ones, there's not too many complicated ones. I would say the more complicated one is probably 10, because it has 2. Same with 8. It's a little more complicated. Let's see. Other than that, I don't think it's too difficult. But looks like this is also going to be a little bit difficult. But yeah, so let's just run through the ones that I think that are going to be a little more difficult. Okay, whenever you see these ones that are sine and cosine, it's probably best practice to just change it into sine and cosine. So we're going to have sine theta. I'm going to change all of these t's to thetas because it's easier to think about. Cosine theta minus cosine theta over sine theta over sine theta cosine theta. Nice. Okay, from here we're going to combine the top terms, because look, it's nice and convenient. We have a sine cosine right here, and we have two fractions that have different denominators that are both sine, that is sine and cosine. So when we combine the denominators, it's going to actually end up being sine and cosine on the bottom, because we have to multiply. So it's nice. So always be on the lookout for those. So just cross multiply real quick. So we're going to get sine squared theta minus cosine squared theta over sine theta cosine theta over sine theta cosine theta. So from here, this actually becomes, since we have top same and then bottom same, it's going to square the bottom. So it's going to be sine squared theta minus cosine squared theta over sine squared theta cosine squared theta. And notice how this this right side, we want it split into two. So from here, we're going to split these into two, and that's going to give us sine squared theta over sine squared theta cosine squared theta minus cosine squared theta over sine squared theta cosine squared theta. And you can notice from here, it's really nice, cancels out. 1 over cosine squared theta minus 1 over sine squared theta. And remember, this is just going to be 1 times cosine theta times 1 over cosine theta minus 1 over sine theta times 1 over sine theta, which is going to give us secant times secant minus cosecant times cosecant. So this becomes secant squared theta minus cosecant squared theta, and that checks out because that matches this side. But yeah, basically that's just the gist of how things are going to go. You always want to find the more complex side, and from there, it's pretty easy. Yeah, I'm going to leave the other ones to you. It's just more important that you really remember the forms of the Pythagorean identity. They are super useful. They will always show up, and I really think it's good to remember those. All right, see you guys next time.